Semester review number 2. This is for the first semester of Earth Science. This review guide is not as long as the real test, but it does cover most of the material that is on the exam in one way or the other. Number 1. What kind of statement is each one of these questions, or each statement? The house is blue. Calling it blue is a quality of the house. It is a description that does not involve any numbers, and so we'd call that qualitative data. Number 2, the house is 30 feet long. This deals with a quantity, a number. How many feet is it? Some kind of a measurement. And so that is going to be quantitative data. The house is beautiful. Well, some people might think that it's beautiful. Some people might think that it's ugly. It depends upon what their values are, what kind of things they like. And so that is going to be opinion. Different people can have different thoughts about the house. Number 4, since the house has broken windows and burn marks, nobody probably lives there. This is an inference. One of the reasons why I can say it's an inference is that it has the word since in it, or I could rewrite it with the word since. It is a train of thought. We have 2 ideas here: broken windows, burn marks. And those 2 ideas lead us to believe a third thing. That is inference, a train of logic. Not everybody might agree with this, but, and in terms of not everybody would agree that nobody lives there, but everybody would agree that probably nobody lives there. Everybody can agree that that is one possibility. Number 5. Below is a picture of a standard ruler. How long does the line measure in millimeters? The numbers that are on the scale here represent centimeters for a standard ruler. And the little tiny tick marks are the individual millimeters. Remember that there are 10 millimeters for every centimeter. So we have 10 here and 10 there, plus another 1, 2, 3. So we have a total of 23 millimeters. Number 6. How long is a line in centimeters? Again, remember that the numbers here on a standard ruler are centimeters. So this black line is not quite up to the 2 centimeter mark. It's a little bit shy. It's going to be 1 centimeter plus 9 millimeters. That will be 1.9 centimeters. Number 7. What's the volume of the liquid in the graduated cylinder? So looking at this, we have 10 tick marks from the 40 to the 50. So each tick mark must represent an individual 1 milliliter. And we read the bottom of the meniscus, the U-shaped thing here, the bottom lowest level of the liquid, and that's the 3rd tick mark up. So it's going to be 40 plus 3 more tick marks, 43. Number 8. Below are shown beams of a balance. What's the mass on the balance? All you have to do is add up where the arrows are pointing. So we have 80 plus 200. And this scale here is reading 3, 1, 2, 3, 4, 5, 6, 7. 3.7. So you just add those up and we get 283.7. Option A. Number 9. All the air that surrounds Earth are the atmosphere. There are different layers of atmosphere that have slightly different qualities, but they're all considered the atmosphere. Number 10, the locations where living things can be found make up the biosphere. The word the prefix bio refers to living things. So biosphere. The atmosphere, as we just said, was all the air around. Number 11, Earth's internal layers. Those are all the different layers of rock and other stuff inside the Earth. And so that would be geosphere. Think of it as geology, studying the rocks underneath us. Number 12, all the collections of water on Earth make up the hydrosphere. The prefix hydro refers to water. Number 13, what data do Earth scientists use to construct the current model of the geosphere? Once again, the geosphere is the geology of the Earth, all the rocks, and the way that they do that is listening to the earthquake waves. Earthquake waves will change as they go from one layer of rock to another. And so lots and lots of careful measurements of earthquakes in lots of different areas from different directions will tell us really good indications as to what is underneath our feet. Number 14, lines of latitude go horizontal, left and right. So that means that this right here, this line is a line of latitude, and this is another line of latitude there. Okay, they measure distances from the equator. So this bottom line right here is labeled 80 degrees. That's 80 degrees on the south side of the equator right here. This line represents 30 degrees south of the equator. The bigger the number, the farther south it is. Or we can do the same thing on the north side. 30 degrees north, 40 degrees north. How far away from the equator are you? Number 15. The lines of longitude go vertical, up and down. They measure distances from, looking at the map, here we have the vertical lines being labeled with these numbers on top, and they tell us how far away from England, or this prime meridian, this zero line that goes up and down through England and Spain and Africa, how far on the west side or how far on the east side you are. Again, the numbers on top, 20 degrees on the west, 40 degrees on the west, 60 degrees on the west, and so on. Same thing on the east. The reason why they chose England is that the folks who made up this system lived there, and the main observatory of the time went through Greenwich, England. So number 15, measure distances from the prime meridian. Number 16, what city is located at 40 east, 15 south? So you find the 00 mark on the map. Here's the equator, that's 0 north and south. And here's the prime meridian, that's 0 east and west. So that's our 00 mark right there. And from there, we want to go 40 east. So that's going to be this way to this line right there. And then we want to go 15 south. So that's going to be right about here. And the closest city is F. This map isn't very good. On your exam, I hope that the letters are much closer to where the numbers come out. But this should be letter F. And, oh, look at there, we have option D, none of these cities. That would be the appropriate thing there. Number 17, what are the coordinates of letter G? So looking for G up here, that's smack dab in the middle of the United States. Going north and south from the equator, here's the equator right there. G is 2 lines up. So it is going to be 40 degrees on the north side of the equator. And in terms of east and west, here's the 0 mark. We are 1, 2, 3, 4, 5 lines. 5 lines on the west side. So looking at our scale, 1, 2, 3, 4, 5. That is the 100 mark up here. So 100 west and 40 north. Oops, I said that. No. So the closest answer here is B. 120 west, 40 north. On the test, I would have those more precise than this. Number 18, we have a time zone map. Number 18, if it is 4 a.m. in southern Florida, what time is it in California? Okay, so here's Florida, here's California, and we have to figure out how many time zones there are between the two. So starting here, we go to this area is 1, 2, and 3 time zones to the left. And just like in a number line in math class, where you have the 0 there and the negatives to the left, since we are moving left on the map, we are going to subtract off 1 hour for each time zone. So we're going to subtract off 3, 1, 2, 3 zones. Subtracting 3 from 4 o'clock gives us the answer of 1 o'clock. Number 19. If it is noon in Illinois, what time is it in Maine? Here's Illinois. Here's Maine. Maine is 1 time zone to the right. On the number line, positives are to the right of 0. And so that reminds us to add 1 hour as we go from Illinois to Maine. Adding 1 hour from noon gives us 1 o'clock. Number 20. A researcher wants to study the way that currents are affected by seaweed growing off the coast of Florida. What field of study is this? Okay, so we're looking at currents off the coast of Florida, so that must mean that it's ocean stuff. Anything dealing with the ocean, whether it be the living things in the ocean or the way the ocean water is working, is considered oceanography. Astronomy is anything in space. Meteorology is anything dealing with the weather. And geology is anything dealing with the surface of the earth in terms of the solid material, the rocks, the soil, and anything below. Number 21. All the areas that contain living things are included in the, it's going to be biosphere. Again, remember the prefix bio refers to life. Sphere just reminds us about areas. It doesn't necessarily always mean a circle or a ball shape. It can just mean area. So this is a living area. The geosphere, that is everything that is solid rock or below us inside the earth. Atmosphere is everything about the air, and the hydrosphere is everything about the water. Remember, hydro refers to water. Number 22. What do you do to test by rubbing a mineral on a tile? If you're rubbing minerals on a black tile or a white tile, you are looking at the appearance of the powder that is created, and that is called streak. The hardness you can tell by trying to scratch the mineral with different kinds of materials like nails and glass and your fingernail and coins and stuff. Luster is the way that the mineral reflects light. Does it look metallic, either all shiny silver or gold, or does it have little speckles of silver or gold in it? If so, all of those things would be called metallic lusters. If it looks like wax or dirt or has a dull color, then it's called a non-metallic luster. The breakage pattern is either cleavage or fracture. If it is cleavage, then it breaks in nice smooth surfaces with straight edges. If it's fracture pattern, then it breaks into random shapes like gravel on the side of the road. Number 23, which vary from sample to sample. Streak does not vary. It does not matter what size of sample you have. If it's a sample of fluorite, it's always going to have the same streak. Hardness. This does not vary. It does not matter if you have a big sample of fluorite or a very tiny piece of fluorite. It's going to have the same ability to be scratched. So hardness does not vary. The same thing is true about all the minerals. Pyrite and muscovite and all that. A big sample is going to have the same as a little sample. Luster is going to be the same for all samples. It doesn't matter which sample of fluorite or muscovite or pyrite you have. It's going to have the same kind of luster, the same metallic or non-metallic appearance. Same thing with breakage pattern. Whether you have a big sample or a small sample of any kind of mineral, if you smash it with a hammer, it's going to break in similar ways. Color is the one thing that's going to change from sample to sample. Some samples of fluorite are more green than others. Some samples of one material might have a brownish appearance, whereas another sample might have a yellowish appearance, but they're still called the same name of mineral. Number 24, luster. Luster is how it reflects light, whether it be metallic or non-metallic. Number 25, what is the contour interval of the map? So we have to look at this map here, and we see the lines with numbers on it. Here we have 500, and up here we have 550. So how many steps is it from this dark line to this dark line? We have 1, 2, 3, 4, 5 steps. So to go from 500 to 550 in 5 steps, that must mean that each one of these steps is 10 feet. So the answer, number 25, is A. Number 26, what's the elevation of the benchmark at the top of Holland Hill? Here's Holland Hill. The benchmark is this triangle, and it's labeled with the number 552. So that's the elevation of that particular spot in this location on the top of the hill. 552, option C. Number 27, what is the elevation of the highest contour line on Aurora Hill? Aurora Hill's over here. Here's the contour line that's the highest on the hill. It's the smallest circle. And let's see here. Here's the 500 line. So this is going to be 510, 520, 530 will be this circle. 530. Number 28, what's the elevation of City A? Here's the A. It is 1 step above the 500 line, so that means it's going to be at 510. What's the elevation of City B? City B is right here, and it is on the line that's labeled 550. Option C. What is the relief from A to B? That's going to be the difference between the two elevations. So you just subtract 550 minus 510, gets us 40. Number 31. According to the scale, how far apart are cities? Oh, that should be A and B. So we look at the scale here, and on a scratched piece of paper, we label 0, 1, 2, 3, 4, and we use that scale up here between A and B, and we can see that it is 3 miles apart. Number 31, the answer is C. Number 32, what's the slope, feet per mile? Now this unit here, feet per mile, should help you to remember that this is the difference in the contour line feet, and this is the difference in the horizontal distance that we just measured in miles. Here we have the feet. I guess this is the feet difference in the elevation. Here we have the miles difference. So we just divide feet by miles. Here we have feet over miles. So 40 divided by 3 is going to be 13. You can use your calculator on the test. If you don't have a calculator, I have several calculators in the front of the room that you can use. Number 33, which side of Girard Hill is steeper? Here's Girard Hill, and we have either the south side as an option or the west side. And here we see the lines are closer together. Here the lines are farther apart. So the steeper area is where the lines are close together. You don't have to go very far west to drop down 10 feet because it's so steep. Here you have to go really far ways south to go down each 10 feet. So that means that it's not as steep. So the west side is more steep. What direction does Colden Stream flow? So here's Colden Creek. They can either go north or south. And there's two ways of figuring this out. One is to look at the contour lines and their numbers. Here it's 500, and we said a few moments ago that this line was 510, and this line was 520, and this one here was 510 and 520. So we can tell that this is going uphill, and so therefore the stream will be flowing downhill to lower elevations. So in that case, the stream is going south. The other way of doing it is looking at these arrows or these triangles that the contour lines are pointing. Those are always pointing uphill, and the stream points the opposite way. And that's the end of the review. Spend the rest of the time working on your first review packet.